What's up, you guys? Welcome back to the channel. In today's video, I'm going to show you how to make the classic game 2048 in Python using the PyGame module. So if you're unfamiliar with the game 2048, you essentially get multiples of 2 and you try to combine tiles by sliding them up, down, left, or right, and you keep getting a new factor of 2 every time you combine two like tiles. And the goal is to get 2048, although those who have played the game before know you can actually go past 2048, and really the goal is a high score where you get points for combining tiles and you want to get as high a score as possible. It's pretty fun, it's pretty simple, and it's super addicting, so I thought it would be a great game to showcase in Python using the PyGame module. Those of you who have been around the channel for a while know I've done a lot of videos on PyGame in the past. It's a really fun, easy to use, beginner friendly GUI package for Python to be able to create games and other sorts of apps. So follow along with the tutorial. If you have any questions or want to see something in a future video, be sure to let me know about it in the comments below. Feel free to take the code from the GitHub link in the description of this video. And if you love the content and you want to support the channel, feel free to check out my Patreon link in the description as well. And without any further ado, let's get into the tutorial. Okay, let's get into programming this game. So as always with games that we use the PyGame package for, make sure to import PyGame right in the beginning. Run pip to install it if you need it. And then go ahead and do pygame.init like this, which will give us access to all of the functions inside PyGame. It just initializes the package. And if you know ahead of time that you're going to have some element of randomization, which if you're familiar with 2048, it randomly populates empty fields in your list with a new tile every turn. So we're going to want the random module, so we'll import that as well. And then we'll just do some initial setup here. So some basic things we're going to need for any PyGame game is a width and a height. And then once you have a width and a height, go ahead and set up your screen by doing screen equals pygame.display.setMode and then width comma height, just like that. And now we're going to have a 400 by 500 screen setup. And then the next thing we'll do is we'll set a caption, pygame.display.setCaption. This is technically an optional step. The default just says like PyGame window, but we'll have it say 2048 because that's cool. And then set up a timer because we want the game to run at a predetermined speed, in this case 60 FPS. So we'll say timer equals pygame.time.clock. And then let's also make an FPS variable. So 60 FPS is plenty fast for any PyGame game. You don't need to go faster than that unless you really want to. And then sometimes I like to use font size as a variable. Sometimes I'll just define it right here in font. But let's just set up a font. And to do that, you say pygame.font.font. If you're going to have any text in your game, in your PyGame game, you have to set up your font kind of ahead of time. Because once it's time to call text, you need to do font rendering, which means you already have to have defined the font. So let's go ahead and just use freesands bold.ttf because that's a built-in that comes with most installs of PyCharm. And then this 24 is me giving it a font size of 24. Okay, so that's really all the kind of boring initial setup stuff we're going to do, and then everything else we'll kind of know we need it as we get to it. So let's go ahead and create the main game loop now, and we'll just create this variable run and set it equal to true. And then our while loop, which is all the game code that is going to loop over and over and over again, we're using that run variable. So while run, and the first thing we're going to do is timer.tick at the frame rate. And then the second thing is just to fill the screen with some background color. So I'll use gray so that we know it's working. And then all we're going to do is find a way to get out of that infinite game loop. So that's kind of the first thing that you want to do when you have a while loop, is figure out how to get out of that while loop, because code really doesn't like infinite while loops. It's going to freak your computer out. So what we're going to say is for event in pygame.event.get, which is essentially PyGame's built-in way of getting everything happening to your computer. we're going to say if event.type is equal to pygame.quit, just like this. And the quit is when you press the red X in the top right of your window that pops up. And we're just going to say if you've pressed the quit button, then we're going to set run equal to false, just like this. And then just two things to get out of here. Pygame.display .flip at the end of the main game loop, which is actually going to throw everything we blit onto the screen and actually put it out there so that we'll be able to see it. And then outside of the game loop, we're going to do pygame.quit, meaning we've exited this while loop and now it's time to close the program. And this should be all we need to do to get the window to open. So let's go ahead and just check that out. There we go. And you can see it's kind of small, but 2048 is a pretty simple game. It's played with 4x4, a grid of 4x4 rectangles. So that's all we need, really. Now let's start taking a look at putting some practical code in here. So first, let's draw kind of the space we're going to populate our board with. So right underneath the screen.fill, we're going to start creating our functions that are going to do most of the code. And I'm basically thinking of it this way. We're going to draw the board, which is going to be like the background, and eventually that's where we'll put like score and high score. And then I want to draw like the pieces, which are draw the pieces, which is going to be the actual numbers, the actual values. And then I think we're going to kind of have like spawning pieces, things like that, where every time we get to a new turn, we're going to put new pieces on the board. So let's just start with these two. Okay, let's start with draw board and draw pieces. And so I'm going to try to label everything because I know people prefer when I label, and I don't always. So let's go ahead and say draw background for the board. And then down here, we'll say draw tiles for game. And let's go ahead and make these two functions. Define draw board. Oh, gotta spell it right. And for now, I'm just going to put pass in there so the code doesn't error out. And then define draw pieces. And again, I'm just going to put pass and make sure I got my formatting right. And then we'll fill in these two programs, okay? So first thing, for draw board, I'm just going to make a generic background rectangle because that's just going to show us where the pieces are going to go once we draw those on top. So I guess the easiest way to do this is just going to be pygame.draw.rect, and we're going to put it on the screen. And let's just give it a color for now. We're actually going to change this to be like the same colors as 2048, the original iOS mobile app used. And we'll do that in just a sec. But for now, let's just make a rectangle with these colors. So 0, 0, 400, 400. And I'm going to make it solid, but I am going to make it rounded like that. And let's just take a look at how that looks. Okay, so it might actually be really difficult to see on the on a smaller screen especially. So let me make this a different color. Like let's make this 230 just to get a hue in there. All right, so you can see this kind of pinkish area. That's where I'm going to draw the pieces because on the bottom of the board, I'm going to show score and high score. And if we have to give any like instructions, that would be a good spot to put it. So if you weren't into showing score or high score, you could just make the board 400 by 400 like a square or whatever sizes you want. But actually, I think the next thing to do would be get the colors from the game. So like 2048 game color library. And here's where I'm going to set up a dictionary that basically says, okay, for any value of tile in the game. So you got to think it starts with 0, and then we're going to have like an RGB value, and then we're going to have 2, and we're going to have an RGB value for that because hopefully you're familiar with the game enough to know every tile changes the color slightly. And so to do this, you're not going to have to sit here and watch me type in 20 colors. I have the color library. I found it online. So using editing magic, we're going to have the colors in there now. Okay. And so what I will say is if you're trying to follow along exactly, pause the video and copy this color library down, or you can grab the code from the GitHub and just copy specifically the color library. Would have been really boring for you guys to watch me type all of these in. But just know these are very close to the colors the original 2048 app used for the different tiles. And so I'm going to be using these going forward. And that's where I got these from. So we're going to come back down in here, and instead of just that color I made up, we're going to address the background colors from our colors list. Okay. And let's go ahead and check out how that looks. You can see it's a little bit easier to see, hopefully. And let's go ahead and continue on. That's actually all I'm going to put in the draw board function for now. And let's go ahead and start making the pieces. Okay. So I'm going to come up to just under the colors library, and I'm going to make a new area that I'm just going to call like game variables initialize, something like that. That'll work. And we're going to make a new list that I'm going to call board values. And this is going to be a list of lists because we want it to be an array. And to start, we want everything to be a 0. So we'll say 0 for underscore in range 4. And the underscore is just a variable, essentially, that I know I'm not going to need later. Like if I used I or J, it would just be kind of annoying. Because it's going to tell me inside of functions that it references outside scope. So I just use for underscore in range 4, and you don't have to use anything else there like X, Y, Z, Q. Don't waste a letter. All right, so that's going to create a board of 4 zeros across and then 4 rows of 4 zeros across. So it's going to create a standard 2048 board with nothing on it. And we're going to need to pass these values, board. We're going to need to pass that into draw pieces. So board values gets passed in there. And now we're going to create our rectangles based off of this. So let's go ahead and take a look. It's going to be kind of like nested for loops. So for I in range, and we'll just say 4 because the board is always 4. You know, if you've watched a lot of my videos, I usually like to say length of board list and then length of board list I. 2048 is always this size. It's not going to get resized. So if you wanted to play a 5x5 or 6x6 or 3x3 version of it, you could replace this 4 with like length of board like that. But I'm going to use 4 because it's always going to be 4. And then we're going to say for J in range of 4. And so this means take each row of data and go through and address each column of the data as well. And I'm going to store that value in a little variable I will just call value. And it's going to be the value of board at IJ. And what we're going to do first is just kind of say if the value is greater than 8, then we want our text color, value color, to be equal to colors and light text. So basically the higher number tiles in 2048 get dark enough that you want light text on top of them. But if the value is less than 8, so like 0, 2, or 4, you're going to want dark text because the tiles are really light. So we'll just say else value color, value underscore color is equal to colors at, and then dark text like this. Okay. So this is basically just choosing what color the text should be. And then what I'll say is if value is less than or equal to 2048, so that's as high as the distinct colors go, then we want the color that we make the rectangle equal to colors at whatever the value of the piece is. But else, we're saying, okay, now you're above 2048. You've gotten to like 4096, or the next one's like 8192, and the next one is too high for me to do the math in my head. But the way the game works is if you get up that high, then you just have this other color, which in our case is black. But you could make it pink or green or blue if you wanted. It basically means you've gotten really, really high. You've more or less beat the game. And so the original game just made it to where they were all the same color, and then I think they updated it later on to go higher than 2048. I'm just saying if you beat 2048, I'm going to make the background black. Okay? But so we've done all this grabbing different colors of rectangles and text. Let's actually use them. So pygame.draw.rect. and we'll put it on the screen, and we'll make the rectangle color whatever color we just picked based on the value. And then here's where using that I and J is going to come into play. And I know that my window is 400 wide. I know that I need 4 rectangles, and I know that I need I want a 20 pixel, 20 spacing gap between each piece. So if you think about it, we need 20 on the left, 20 on the right, and 20 in between each of them. Well, that's 5 spaces of 20. So we have 300 spacing that we want to fill with rectangles. 300 divided by 4 is 75. So what that means for the rectangle is we want the X starting position to be J times 95 plus 20, and we want the Y starting coordinate to be I times 95 plus 20, and we want it to be 75 wide and 75 tall. And let me just talk about this really quickly, why these 4 values. These first 2 are the top left and right corner. So if you think of the first square, it needs to be just 20 by 20 off of the screen, and I and J are going to be equal to 0 and 0 for that. But then for the second one, you want it to be 20 gap between the 2. So if this was 0, the first one starts at 20 and goes to 95. Now if it's 1, it's going to start at 95 plus 20, so 115, and then it's going to go to 210. So I think you'll see as soon as we boot this up what it looks like and why we picked these dimensions. So then I'm going to make it solid, and I'm going to also make this a rounded rectangle with radius 5. Let's go ahead and take a look at that. And you can see, because we have all zeros, that we don't have values on there, but you can kind of see just the light placeholder squares for all the pieces that have values of 0. But what we can do just to test really quickly is put a 2 in there instead of a 0 for the board values. And you can see it's a different color. It's a little more vibrant. Let's go ahead and climb the chain a little bit. Let's put a 4 in there. It's still pretty light, but it's clearly a different color. Let's jump right to like 1024 and see what that makes the squares. Okay, it's this dark yellow. So you can see it is working to take the value and look up what the color should be for that based off of that. So now let's do the second thing, which is going to be putting text on those squares. And we're going to do this in I think it's kind of a smart way. So just try to follow along. I'll explain it as we do it. We basically want to say if value is greater than 0, because the way the game works is when you have zeros in there, it doesn't tell you 0 like it's a real square. It just looks like a blank background, like what we've been looking at already. So if value is greater than 0, we're going to start by checking the length of the value. So the length of the string conversion of value. And the reason for this is we want the text to be as big as we can, but still fit on the rectangle. So if it's only 1 character, we can have a pretty big font. But if it's 4 characters, like 2048, we need the font to get a little smaller. So what we'll do is we'll say font is equal to, and I'm actually going to copy the initial font that we set up above. And now we're going to do something pretty neat with the font size. So we're going to say pygame.font.font with a capital F for the second one. And now we want it to be as big as it can, but we want it to shrink as the number gets bigger and bigger to make sure it fits on the screen. So to do that, I'm going to say 48 is kind of my baseline, and that's a big number. But then I'm going to subtract 5 from my font size for every character I have of the value. And this is something I came up with while just playing around with it, because 4 wasn't really shrinking it enough. 6 was a little bit of overkill. So I found 5 was a really comfortable amount to shrink it every character. Once I get this drawing on the screen, I'll show you what it looks like getting smaller and smaller values. Or I guess larger and larger values for a smaller font. Okay, so we've defined the font. Now let's go ahead and define the string, which is value text. And it's just going to be font.render. And then the string we're going to give it is just a string conversion of the value. Oops. Don't need the apostrophes there because str converts it to a string. And then true for anti-alias, which is the second argument you give strings. It's always true. I've mentioned this in previous videos. I don't know what happens if it's false. I always put true there. So anyways, and then the color we want the text to be is that value color we came up with earlier. And now what I want to do is I want this to always be in the center of the rectangle, which is actually kind of tricky to do when you have something that could be multiple different characters. So the easiest way I've found to do it is define a text rectangle, which is essentially you look at your string that you just made, value text, and you use the .getRect function, that's built into PyGame. And then you define where you want the center to be. So you say center would be at j times 95. So think of these rectangles that we're building. But then plus 20, but we want to be at the center of the rectangle. So plus 20 and then half of 75, which is basically 37. So plus 57 and then I times 95 plus 57, like that. And all we're doing is defining an x and y coordinate we want to be the center of our text. Okay, like this. And then what we do is we say screen.blit and then the text, value text, and then we give it an x and y coordinates, and it's going to be text rectangle. So we've already defined the rectangle that that the value text is going to occupy and said the center point will be the center point of the rectangle that we just defined that's going to hold the value. Okay, and then this is an optional step for sure, so you can skip this if you don't like the way it looks, but I like putting like outlines on my rectangles. So now I'm just saying the exact same rectangle that's going to hold the value. I'm just going to give it like a width of 2, not 20, 2, and it's just going to be a thin black outline of the rectangles. But okay, if we boot this up, right now it's not going to give us anything because we only have zeros in there. So let's go ahead and take a look at what it looks like with 2s. We should have a board full of 2s. There you go. And you can see the outlines here. And now let's make it one font size smaller. So hopefully you can see as we put a 16 in there, it gets even smaller. And let's see, what's a 3-digit one? 256. So this should make it smaller so that it continues fitting in nicely, and you can see it does. And let's go ahead and just try 2048. Okay, let's try the big one and see that it fits. And you can see it fits pretty good, and it fits because we're shrinking the font the more characters you have. So I think this looks really good. We're drawing a board in a way that's going to be dynamic enough to handle any value we get during the course of the game. And that's really cool. So I think it's time that we start with the kind of gameplay. So let's go ahead and take a look, I guess, first at how to spawn in a new piece. And I think we're going to make this to where it's pretty versatile. So now we're going to come down below our draw board and our draw pieces. And we're going to make a variable for when it's time to spawn new. So we'll say if spawn new, which maybe you don't like the word spawn, but that's kind of what it means, is like come in, come from nothing. So if spawn new, which will be a true false variable we'll put in, then what we'll do is we'll make this function that's going to be like new pieces. And we'll give it board values. Okay, so we're going to pass in those values, and we need to also get board values back because we are going to be able to modify them from here. And then we're going to set spawn new equal to false. Okay, so we need to make this new function new pieces. So we'll come up here and we'll just say spawn in new pieces randomly when turns start. Okay, and I think I called it new pieces, and we're giving it the board, and we're returning the board. Okay, so the way we're going to do this is actually pretty easy in my opinion. We're just going to randomly pick a row and column, and if it's empty, we're going to populate it. Okay, so I'm going to say while, and this is actually a pretty important step, while there is a 0 in row for row in board. And this, I want to talk about this real quick. This is checking to see that there is some 0 in some row inside the board. So this is kind of, in my opinion, the easiest way to check, do I still have an available space in my board? I spelled randomly pretty wrong here. So basically this function says, while I have a 0, then what I'm going to do is I'm going to select a random row and column. So random.randint from 0 to 3, which could be any row, and then column is going to be the same thing, random.randint from 0 to 3, which could be any column. And then if board at row call is equal to 0, then what we're going to do is say, well, so ordinarily you would just make the new piece a 2, but actually the way the game works, 2048, at least according to what I found on the internet, is there's a 1 in 10 chance that you get a 4, right? So it almost always gives you a 2, but now and then it'll give you a 4, which I don't know why they made it that way, but let's do it the same way. So this means that we've found an empty space in our board, okay? So if the row and column is equal to 0, then what we want is if random.randint from 1 to 10 is equal to 10, okay? So this is going to do a selection that should give us a 1 in 10 chance of getting a 4. Then we'll say board at row call is equal to 4, and then we'll just say else. And then we will just say else board at row call is equal to 2. Okay, sorry about the brain fart. And let's go ahead and just say, so the alternative of this, I guess, would actually be that the board was full. So what we probably want to do for that is make this variable checking if it's full or not. So we'll say, I was thinking over like game over, but we'll just call this variable full, and it's false, okay? But if we don't have anything in here, then full is actually going to be equal to true. So actually this would be the way to do it. Say the board is true right when we get in here. Say that the board is full, but as long as we find something that is, as long as we find something that's equal to 0, then we get to say full is equal to false. And we're going to return this with the board function, because later when obviously right now we're not close to game over, but eventually we want to check if game over is true or not, and game over is going to be true when there's nowhere left for us to put pieces. That's how the game ends. You've completely filled the board and you can't put any new pieces on. So this will be really useful later. And so we're going to come down to where we had said we're getting board values back, and we're going to get this variable game over back, which we'll use later, but it's good to have that in place already. And since we were there doing that sort of code, it's good to get it set up in the first place, okay? So basically what we're going to say when the game starts is spawn new is equal to true, okay? Excuse me. And now let's take a look. When I start this up, it should give us one piece that's a 4. That's interesting. Okay, I see what's going on. We're saying, well, any 0 is still in there, just keep populating the board. And actually what we want to do is keep track of how many new pieces we've made. So we'll say and count is less than 1 for now, because we only want there to be one new piece every time we call this function. So I'm going to make this variable count equals 0. And then while any and count equals 1, and actually the easiest way then to fix this will be not put it in the while, just say if count is less than 1, then full is equal to true. And then that way when we first boot this thing up, we can actually assume that full is equal to false, okay? So basically what I just changed this to do is say when it boots up, okay, we haven't made any new pieces yet. And then when we find an empty space, increment count by 1, and then just say if we weren't able to add 1, then that must mean the board is full. So now if I run this, it's going to give us 1, 2, okay, which is great. That's what we want, except the actual first step in 2048 gives you 2. So probably the way we want to do this is just call the function twice. So right when we boot the game up, we're going to say init count equal to 0. And then we'll just say when we first if spawn new and init count is less than 2, then we're going to say spawn new, and then we'll just increment init count by 1. And then this is it might seem like overkill, but we're just saying when the game first starts up, do this twice. And it didn't work. Oh, because this should be or init count is less than 2. There we go. Let's see. There we go. We get 2 pieces. We got 2 number 2s that time. And basically, we want this to be as close to the real 2048 as we can. So that's just saying, give me 2 randomly generated pieces. And now when we have a new turn, we're just going to run that function once. So we won't reset init count. Okay, so let's take a look at taking turns, because that's the most important thing that we have left to handle. And we're going to come down into our event handling, where we have for event in pygame.event.get. And we're going to add a new type of event in here. So we're going to say if event.type is equal to pygame. And I'm going to use key up. You could really do this code with key up or key down. I just think it's a little easier to say you've actually taken a turn when key up is true. So it just means you're releasing the key. Most of the time you're just tapping keys anyways. So key up and key down, you're not really going to notice a difference, but I prefer key up. And so I'm just going to make a new variable that I'll call direction. And depending on what key you press, so I need one more thing in here. If event.key is equal to, what did I do? If event.key is equal to pygame.k underscore up, like that, then we want to just make this text direction, this variable direction that I just made, equal to up. And we're going to do this 4 times for the 4 arrow keys. Boy, it's not nicely formatting for me today. There we go. If, and then if we press down, then we want the direction to be equal to down. And then the last 2 are left and right. Oop, good heavens. It's just end of the week jitters, I guess. Something like that. Okay, so key left, like this. And then left, and then right and right. You could use like an integer variable and just make them like 1, 2, 3, 4. But it's not that hard using text, so we're going to do it this way. And what I'm going to do when it's time to take a turn is I'm going to come up and make a new if statement that's basically going to say if direction is not equal to an empty string, then what we'll do is we'll change the board values again. That's what happens when you take a turn, equal to this function we're about to make called take turn. And basically what we're going to pass in there is the direction of the turn we're taking and the current values of the board. And then we're going to go ahead and set direction equal to that empty string. And then we're going to say it's time to spawn something new. Okay, so hopefully this makes sense. This is how a turn in 2048 goes. It's going to spawn your initial values, and then you're going to click an arrow key to take a turn, and then it's going to move the pieces, combine them if it can, and then clear out your turn, which is resetting the direction string to, nothing. And then it's going to spawn in 1 new tile. And that's basically how the game works. So once we've defined this take turn function, we're going to be almost all the way home. We're just going to add some functionality at the end. So take your turn based on direction. And we are going to define this function, take turn. Okay, and we are passing 2 things in here. We're passing the direction and we're passing the board in. And this, I'm just telling you ahead of time, the take turn function is going to get a little bit complicated because we are going to check through every row and every column and see how many spaces it can shift based on the turn that we took, which means 4 different ways of parsing nested for loops. And so it's going to get a little complicated. If you have questions about what you see in this video, feel free to ask them in the comments below. I am anticipating this confusing some people, but it's also some pretty cool code once you get the hang of it. So let's dive right into it, but I know some people were going to be a little confused by what's going on here because it's hard to visualize. So just let me know if you have questions. All right, so to start, let's go ahead and just make like an if else kind of series for the 4 directions. So we'll say if direct is equal to up, and then I'm just going to say pass for now, which pass is just like dummy code so that I can put all of them in here. And then I'm going to say elif direct is equal to down, and if it is, then pass. And then elif direct is equal to left, then we're going to pass. And then elif direct, and you could just make this an else because it's the only other way you can go, but we're going to pass in that case as well. And then really all we're going to return at the very end is however the board looks once we've modified the board. So okay, so this is basically just saying I'm going to process these 4 different turns, and I'm going to do it all in one function. It's not the worst idea in the world. You could make a define turn left, turn right, turn up, turn down function if you wanted these to be 4 different functions. I'm going to group them all together here, but it is going to be a lot of code by the time we're done. Okay, and an important thing in 2048 is per turn, squares will only merge once. So if you had a 2 and a 2 and a 4 all stacked together and you tried to merge them, that 2 and that 2 are going to merge into a 4, but those 2 4s are not then going to turn into an 8 all in that turn. And so that means every square can only merge once. And so we need to create a list that keeps track of what pieces have merged and what ones haven't. And at the beginning of every turn, nothing has merged yet, right? So we're going to make a list to track which ones have and haven't merged yet. And in the beginning, they're just all going to be false because nothing is merged. But then as we go through the 4 directions and we say, well, these are the times you would merge going upwards, we're going to keep track of that in this separate list that we call merged, okay? So let's take a look at how to move everything up, okay? So we're going to start with for I in range 4, and then for j in range 4, which is just an easy way of saying we're going to go through every square on the board. And initially, the amount that piece should move is going to be 0. So we're saying we're going to check how much each piece gets to move based on how many zeros are in that direction for it on the board. And so to start out, we set this variable shift equal to 0. And then I'm going to say if I is greater than 0, meaning if you're in a row that isn't the top row, because if you're in the top row, there's no point checking. You're not moving up. You're already all the way up. Okay, so if I is greater than 0, I'm going to make another for loop for q in range I. Okay, so this is saying now I want to know how far down you are. So if I is 1, then I'm only going to check if row 0 is empty. But if I is 2, I'm checking if row 1 and row 0 are empty. So if the board at qj is equal to 0, so this is a little for loop that's going to check every piece right above my current piece and see if it's 0. And if it is, I need a colon here. If it is, then I'm just going to add 1 to my shifter variable, okay? And then that's it for that for loop with the q. And then I'm going to say if shift is greater than 0, meaning I found zeros above my piece, well, I'm going to set board at I minus the shift minus 1, meaning my current spot and however many I move up. And so I'm checking to see if there's, I'm skipping around here a little bit. Okay, if shift is greater than, not this minus 1, here we go. If shift is greater than 0, that means I found zeros above my piece. So I just move my piece up by however many zeros were there. And the reason we can do it this way is because we're starting at the top row. And so first we check the second row, which is row 0, which is row 1 by index. And if that piece has zeros above it, we can move it up and then make whatever space it just vacated a 0. And then the next row is going to see that that spot is now a 0, and it's going to move up to fill it. So this is actually a pretty cool way of kind of shifting all the values in an array. So basically, after we've moved it, we want to move the space that it just moved out of equal to 0, because now it's an empty space, and we want the next piece we check to be able to move into that space if it wants to. Okay, but then we want to check if our piece collides with the spot above it. That's really the game of 2048, is merging. So we're going to say if I minus the shift minus 1, right? So we're moving further up at j is equal to the board at I minus shift. All right, so our new piece, shift j. So if our new piece and the piece right above it for the turn going up, if they're the same value, then we want to update it to where the piece above it gets a value of double. So if it's two 2s colliding, it turns into a 4, and then the lower value is going to turn into a 0. But to do this, we also want to check that those pieces have not already been merged. So we say and not merged, and we're going to say basically I minus shift minus 1 and j. Okay, and this is going to be kind of a long rung of conditions, so I'm going to add the and to the next row and just say and not merged, and then I minus shift and j. So basically no piece can have already been merged. And I think I'm gonna jumping all over the place. I want to put a backslash here just to say my conditional goes to the next row. All right, but this is basically me checking and saying the collision above me is with a piece of same value. So I want to update my board so that board at I minus shift minus 1 and then j times equals. So this is just an easy shortcut for saying double whatever value you already have, and then clear out the value behind you. So board at I shift j should turn into a 0. All right, and then what I need to say is that merged at I minus shift minus 1 is equal to true, right? Because we're saying the piece that now is going to have a 4. Like if this is 2 2s and it turns into a 4, that's the piece that now has been merged. All right, so this should be all we need to be able to take a turn upwards. So I guess let's go ahead and load this in and see if we get the ability to move these pieces up. Oh, I didn't initialize direction right in the beginning, so nor did I count. All right, direction is initially going to be equal to an empty string until I give it a command. So let's go ahead and run, and this is init count. Oh boy, silly formatting. Okay, well these are already on the top, so if I press any arrow key, I get a new 2. Now I'm going to press up, and what I hope happens is this 2 populates this spot, and then we're going to spawn in a new piece. And it says Boolean is not subscriptable. Let's take a look at what we did. Okay, silly mistake, but the Boolean object is not subscriptable. We're trying to write true to whatever we're merging with, and this needs to have 2 coordinates, right? It needs to have a row and then a column, and we were just giving it the row value. So let's see if that takes care of it. Yeah, so we can move that 2 up. Let's see if I move this one up. Good, good. Let's see if I can get them to stack. There you go. Hopefully you saw those 2s combine to a 4. We're getting 4s. That's cool. Let's see. Yeah, we get an 8. I'm just going to hit up because that's the only turn we have configured yet. But we'll probably just get, yeah, we're just going to get, we're going to fill the screen. But that's actually okay. We should be able to simulate kind of game over scenarios just with up. And you can see that's cool. The numbers are combining, but we've only done one direction so far. So hopefully this is cool, and hopefully you understand what's going on here. Just to briefly reiterate, we check through every space for the direction up, and we check how many zeros are above it. And that tells us how many spaces up we can move that piece. And we start at the top. And then if we move that piece up, we rewrite the piece that we rewrite that space to be equal to a 0 once we move it upwards. And then that means the next piece down that we check is going to register that space as a 0. Then once it figures out how far it can shift upwards, it checks to see if it collides with the next piece. And if the next piece has the same value as it, they merge and they leave a 0 behind. So it's sort of, I think it's a pretty elegant way of doing it. Maybe you have a better way that seems more logical to you. If you do, definitely let me know about it in the comments below. I love hearing from viewers about what they did to make their code run a little better. So, okay, next let's check out going down. And we're going to do this one just a little bit different because obviously going down, you actually want to start off by checking the bottom row and then going up. If you think like the way the game prioritizes movement is when you go up, whoever's on the top should be the first one to merge and the first one to move. But then when you go down, it's the opposite. It should be whoever's on the bottom. And that can be a little tricky since for loops always start with 0 and they go up to but not including whatever you make the range. So let's take a look at how I want to do this. We're going to do this a few different ways to hopefully get you familiar with using for loops. But so again, i's and j's, and we're going to set shift equal to 0 initially here. And then what we're going to do is say for q in range, and this time let's go ahead and say I plus 1 because we actually want it to do for 0. We want it to be for 1, 2, or 3, just the way I'm writing this. And we're going to say if board at 3 minus q, okay, and then j is equal to 0. You really don't have to think about j too much for this one, just like you aren't going to think about I too much when we do left and right because we're only moving vertically right now. But what this is saying is, okay, I'm going to start from essentially the second row up from the bottom. So if you think about the indexes being 0, 1, 2, and 3, I'm going to start at 2. And the pieces that I'm checking to see if they're zeros are going to be 3 minus wherever I'm at. So if 2 is the first time I run through this loop, that means my indexer is 0. Okay, so I want to check if board 3 is equal to 0 and then everything up from there. All right, so basically if board 3 minus q j is equal to 0, then we're going to add 1 to the shifter. So this is basically us doing the same thing we did for up, but in kind of a backwards way now, since we're going down, and it's a little harder to process arrays that way. Okay, but then if the shift is greater than 0, we're going to say board at 2 minus I plus the shift is equal to, and then at j, is equal to board at 2 minus I j. Okay? And then we go ahead and clear board 2 minus I j out. So that's equal to 0. And now that we've shifted everything down as much as we can, and again, you're probably noticing we're starting this one. We're doing it a little different. I forgot the word in. But we're doing this a little different. I'm not even bothering to check the bottom row with this one. So with up, I did 4 and 4, and we checked the top row. It's just obviously there's nothing above it to check. You could do something standardized for both. I want to show either is actually valid as long as you understand how to write your for loops. And then what we're going to do to check if we should merge is first I'm going to add this conditional that says if 3 minus I plus the shift is less than or equal to 3, because I don't want to check pieces that are off the board to the bottom. It's going to throw an error and say the index is out of range. So I'm basically just saying, okay, is the piece below me actually a piece that's on the board. So it's just a quick cover my butt thing so we don't get a bunch of errors. But basically what we're going to say is, okay, 2 minus I plus the shift, right? Which is whatever piece we just moved into. And then at j. And if that's equal to the board at 3 minus I plus the shift. So this is the piece that's right below my piece. Okay? And then and not already merged at 3 minus I plus shift j. Okay, so basically just making sure that my pieces and then backslash, and we'll keep writing it down here. And making sure that neither of my pieces have already been used in a merge, because you don't want to do 2 in one turn. And there we go. So it's a long conditional, but it's, you know, important. And then we are going to take, same as kind of the before, we're going to take that bottom piece, which is 3 minus I plus our shift calculation. And we are going to multiply it. So times equals 2. And I'm going to give this a little extra indent so it's more clear. It's not it's not one of those conditions. Alrighty, so we're going to make the bottom one doubled, and then we're going to clear out the one above it. So board at 2 minus I plus shift and j, and I should not have had caps lock on for that. So we're going to do that one again. Board at 2 minus I plus the shift j is equal to 0. And let's go ahead and mark the merged as true. So 3 minus I plus shift and j is equal to true, like that. Okay, and let's go ahead and test. Now hopefully up and down is working. So I should be able to merge these going down, and I get a 4 and it sits at the bottom, so that's pretty cool. Let's go up, 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 just generate a few more. Let's merge these, so we should get a 4 right here. And we do, and let's move them down. That's pretty cool. I mean, up and down is working. Obviously, it's not much of a game yet because we can't move left and right. But it's actually pretty fun just to click up and down and get them moving. So that's cool. We're going pretty good. We're doing pretty well here. Let's go ahead and move the pieces left and right now. And then we'll have all of the directions covered. Okay? So for going left, it's a little bit more like going up because we get to start from 0. So for I in range 4, and then for j in range 4, the shift is going to start out as 0 as always, and then for q in range, and the number of spaces we check through now is whatever j is equal to. And I said if I instead of for I, because I typed too fast. Okay, so for Q in range J, we're going to check and see if board at I Q now is equal to 0, and that's what we'll use to decide how much to shift by. And then we are going to say if the shift is greater than 0, then board at I J minus the shift gets set equal to board at I J, just like this. And then we're going to take board at I J and set that equal to 0. And now we check for merges. And this one, again, it's pretty easy because going up and going left play a little nicer with the native way that Python processes for loops. So to check for collision, we say if j minus shift is equal to the board at I, and then j minus the shift minus 1. So essentially one piece further back to the left, and we have not already merged either of those pieces. So I'll just grab this I, j minus shift 1, and then a backslash, and we'll continue down here, and not merged I, j minus shift. So hopefully the steps are starting to make sense to you and you're recognizing them as we do them for each different direction. But I do understand if it's still kind of a bizarre concept to you. nothing particularly clear about processing arrays and shifting them all up, down, or to the left. It sort of makes more sense when you see it than when you write the code for it. So a lot of guess and check sometimes involved in getting your arrays to move the right direction, but I hope this is fairly straightforward. Okay, so we take the one further to the left in the event of a same value collision, and we're going to double that as we've been doing, and then take the one we just vacated, which is j minus shift, and setting that equal to 0. And then we update our merged list so that I, j minus shift minus 1 is equal to true. Okay, and that should take care of left. It's not a bad idea to boot it up and test it here real quick. So I can move them to the left, I can merge them to the left. That's looking pretty good. So now I have up, down, and left, and you guys hopefully who are keeping track at home know that only gives us one direction left to take care of. Let's do right, and then we will be done with this super confusing turn-taking kind of code. And they say a good teacher is able to take complicated things and make them simple. I do not know how to make this simple, so I guess that means I'm not that good of a teacher. But I'm doing my best, guys. All right, so now we're going to say for going right, it's a bit more like going down for Q in range J. Except you'll see I'm going to do it with the full range of 4 because, again, I want to make this clear. If you know how to use your for loops, you can do this a few different ways. So pick whichever one makes the most sense for you. But we are now checking to see if the board at I and then 3 minus Q. So essentially starting from the right and moving to the left as we check. And we're checking to see if that's equal to 0. If it is, then we just update our shift variable. And then at the end of doing that, we say if the shift was greater than 0, it's time to move our piece. So that's going to be piece at I and then 3 minus j plus the shift. So we are shifting to the right now. 3 minus j plus the shift is equal to board at I and then, oop, I got curly brackets in there. At I, and then whatever 3 minus j is equal to. All right, and then we take board 3 I, and then 3 minus j, and we set that equal to 0. Okay. Now, we're going to say if 4 minus j plus shift is less than or equal to 3. And the reason for that is because I decided to do this with a 4 instead of a 3 like when I went down. But essentially, you need to check that while you check for your collision, you're not checking for a square that's off of the board. So that's why now it's a 4 minus j plus the shift. And what we're going to say is if board at I and then 4 minus j plus our shifter. So this is whatever's 1 to the right of the spot we just moved into, is equal to board at 3 minus j plus the shift and not merged at both those points. So let's just go ahead and copy backslash and not merged, tab that in a little extra, and copy this location. Oh, forgotten I. We were going to get another error and then another annoying troubleshooting session. And so we're just basically saying, okay, that means we have two values that should collide. They have the same value, and they haven't yet merged. So just like always, we take that destination one, whichever is further to the right, 4 minus j plus the shift, and then times 2 times equals 2 to double the value of it. And then take the further back one, board I, 3 minus j plus the shift, and set that one equal to 0. And then we want merged at I, 4 minus j plus the shift to be true. Okay, so I apologize. I know how long a section of the video that's going to take up, but we should now, that's really the entirety of playing this game. So it's not surprising it took a few minutes, okay? So let's go up. We get 2s. Let's merge those 2s. Let's go right, down, left, up, right, down, left, up, right, down, left. So this is pretty cool. You have the whole game. This is literally how you play the entire game of 2048. You can see the colors are updating. If this is a game you've played on your phone, then you're probably familiar with these colors as well, and we've got it really close to looking like the original style as well. So I know that functionality is a little bit complicated, but it's actually the reason we spend so much time doing that is because it's such a big part of the game. That's the main gameplay. So just if you understand this take turn function, you understand the entire way that 2048 works. And if you have specific questions, again, let me know in the comments below. Let's go ahead and take a look at how we would score this thing. So let's start tracking some score. So right in the beginning, when the game boots up, let's go to our initial values. We have a score of 0. And we're going to say that this initial high score is something we're going to load from a text file. So I'm going to make a text file and put it in my game folder, and I'll call it high score. And I'm just going to put a 0 in there to start. But I think this is something where you might want to keep track of the high score as you come back and play it again in the future. So we're going to use this file open that we've covered a few times in a few different games where we've been saving scores, but it's file equals open and then the name of your text file. Mine is high score, and then comma, and then you say R for read, and then to actually read out of that text file, I'm just going to say init high, which is like initial high score, is going to be equal to an integer conversion of file.readline, like this, okay? And then we are going to close the file because that's good practice. Once you've had the data, once you've read the data out of a file that you want to, go ahead and close it. And we're going to set our high score variable equal to init high. And you'll see why we're keeping those in different variables in a little bit. But that's just kind of the core of how I'm setting up this game to be able to do a local just for this game score, and then also an overall like high score. So let's come down into our draw board function, because obviously right now it's one rectangle, right? It's not doing much for us. And what I'm going to do is I'm going to add some text. Okay, so I'm going to say score text is equal to font.render, and I'm going to make this an F string, meaning I can combine variables and text right here. So I'm going to say just F score like that, and I'm going to anti-alias it as true, and then make it black text. And I'm going to do another string that I'm going to call high score text, and it's going to be basically the same thing, font.render F string, and instead this will say high score colon and then high score, still true. Oop, that comma's got to be out here, true, and then still make this black. And we're going to put this in that lower section of the screen. This is why I left 100 pixels, 100 space open at the bottom. So score text, and then 10, 410. So that's how far down we want to put it. And then screen.blit high score text, and then that one will keep it at 10 pixels from the left edge and 450 from the top. Okay, so this is great, except we don't track score or high score in any way right now. So let's go ahead and take a look at how to do some scoring, okay? So inside of our main game take turn function that we just made, the way we're going to keep track of score is actually really easy. I'm just going to call global score like this. And what we're going to do is anytime we merge a piece like this and say, times 2, we then add that value to the score. So we just say, okay, well, you've just become worth 4. And the way the game works is you get that much score. So when you take 2 2s and you turn it into a 4, you get 4 points. That's how scoring in 2048 works. So that's really easy because of the way we set up the game. All right, so we just come down into all 4 of the different turns, and we say in the situation where you've collided with another piece and then increased your value, I'm just going to add that value to the score. So this is kind of the beautiful thing of working with a number-based game. You have already, the value is also like the amount of points you get when you merge, which is pretty cool. So that should be all we have to do for basic scoring. And then for high scoring, it's pretty easy. We're just going to come down into our main game loop pretty near the bottom. And I'm just going to say if score is greater than high score, then high score is equal to score. And this is going to be how it works. We don't have a way of restarting just yet, so we'll take a look at doing that next. But let's just check if our basic scoring is working, okay? So I'm going to merge these two 2s going down, and I get 4 points. Great. Now I'm going to merge those 4s, and I should get 8 more. So I have 12. Terrific. And now I have 20, 28. So this is great. You can see the score totalizing is working. I'm clicking really fast because I'm just trying to jack up the score. Well, I'm actually doing pretty good, going really, really fast. But yeah, okay, so that's great. That scoring is working just like 2048. Next thing we should put in is how to restart if you fill up the board, if you lose, if you have game over. So let's do that in our event handling. That's the easiest spot to do it. And let's say under key up, if game over, right? If the board is completely full, then we'll just say if event.key is equal to pygame.k underscore return, and I put a space in there for no reason, pygame.k underscore return, like that. So return is the enter key. Pygame was written a few years ago. Old school keyboards would say return on the enter key, so maybe you already knew that and you're tired of me explaining it, but I want enter to be how you restart the game once you've lost. And basically, we're just going to reinitialize a whole bunch of stuff once you restart the game. So we're going to set everything back equal to 0. So for underscore in range 4, for underscore in range 4, our little array of zeros for our board. And then spawn new is going to be equal to true. Init count is actually going to go back to 0 because we want to reinitialize the first 2. Score is going to reset to 0, but not high score. And then direction, we want to clear that back out. And game over is going to go back to being equal to false. False. And this is the time as well that we want to check. We want to, first off, when game is over, we want to draw onto the screen. So I'll come up here and say that if game is over, this we want to do in a different spot than inside event handling. We want to do this as soon as game is over. Then we're going to make a new function, which is just draw game over stuff. It's basically going to be text that says game over, press enter to play again. But once game over triggers, what we'll do is we'll check if high score is greater than that initialized high score that we read in right in the beginning. And if it is, we're going to write our new score into that file. So we're going to open up our high score file again. And this time it's going to be a W because we want to write to it. And then we say file.write, and we say what we want to write in there. And it's going to be high score, which I'll put in these curly brackets and do an F. You could just do str and then parentheses and high score. That would do the same thing. But we're going to write, and then we're going to close it, basically saying save my data. And then we're going to reset this init high equal to whatever we've registered as the high score. So this is a little bit easier than writing to the file every time we get a high score, like during an active turn. So I guess one thing to note is if you had a previous high score of like 2,000, and then during a run you got to like 2,200, but you didn't end the game, you just hit X, it's not going to save it because we only save it once the game is over. It saves a lot of processing power that way, but you might miss like a live update. So just know that's what's going on here. And now let's just really quickly get this draw over thing in here. So I'll just say draw game over and restart. Draw game over and restart text. Okay, and we called that define draw over. And we don't need to pass any parameters in because it's just going to be some drawings. My chair keeps shrinking. All right, let's go ahead and just draw like a black rectangle. PyGame .draw.rect, put it on the screen, and let's make it black. And we'll put it 50 to the right and 50 down from the top. We'll make it 300 wide and 100 tall. And we're going to make it solid and a rounded rectangle with a pretty wide radius on the corners. And we're going to make this game over text1 equal to font.render and just text that says game over, like that. And then anti-alias is true. And because this is going on a white rectangle, black rectangle that we just made, let's make the text black. And then let's take game over text1 and basically copy it to make game over text2. But this one will say press enter to restart. And I'm sorry, this is going on a black rectangle, so we want to make it white. I think I said that right, but then I typed in black, which is awesome. Okay, so let's blit these onto the screen in the event of a game over. And so game over text 1, and this one we'll put a little bit further in, so 13065 because it's kind of short text, but still on top of that black rectangle. And then screen.blit game over text 2, and this one we'll put underneath it, so we'll put further down on the Y but farther back on the X. So essentially we want them both to look kind of centered on the rectangle, but I'm not in too much of a rush to make it perfectly centered with the rectangle format that we did earlier. So I'm just going to hit up until I kind of trigger game over, and we should see, there we go. Game over, press enter to restart. Now let's see when I hit enter. Okay, it gives me a new board, which is great. It resets the score, but not the high score, which is great. Now let's check my high score file, and it's actually got a 104 in there, which is great. Now the next time I boot this game up, it already says high score 104. So that's really cool. That's how you track high scores from previous runs. Okay, so let's go ahead and just let PyGame do its automatic cleanup reformatting. But I think this is really the complete build. So we have the ability to store high scores from previous runs. We can move up, down, left, or right by processing the entire array. And you can really play the full game of 2048. We have a lot of really cool functionality. We use the same general color scheme as the original game of 2048. I think maybe if you wanted to take this game the next level, if you wanted to improve the style of it, you could make it to where when we shift those pieces, if we determine they need to slide to the left or slide to the right, you could actually have them slide, because what I'm currently doing is I have them snap into place. And I think the original game maybe actually moves them. You could do that just by keeping like an intermediate table of how much each piece needs to shift, and then you move it by that many pixels over the course of a certain number of scans. I'm not going to do that in this video. It's already getting pretty long, and ultimately these projects get way cooler when you take them yourselves and you add functionality to them and you really make them your own. So I hope you really enjoyed this project. If you did, please leave a like on the video, subscribe to the channel. It helps me out a ton. Leave a comment letting me know if you liked it, letting me know what you want to see on the channel next. If you feel like becoming a super supporter of the channel, check out my Patreon link. That helps me out a ton, and let me know what you want to see in a future video. As always, thanks for watching and good luck with your code. Thanks. Bye.